Okay, pre-cal 12, let's get after it. We are diving into arithmetic combinations of functions. So, what does that mean? That means we have two functions. Okay, in this case, we're going to call them f of x, g of x. Okay, and I've kind of highlighted this for you right here. Now, the notation is important because if you have a function f of x and you're adding a function g of x, you can write it as the addition of f and g of x. So what does this look like? Well, here you have f of x is 3x plus 2 and g of x is x squared minus 4. So if you're adding those two functions together, you are literally just adding those two functions together. Now, when you're adding, it's not a huge issue, but when you're subtracting, brackets would be super helpful. It distinguishes between the next two functions. Again, adding isn't a huge issue because it doesn't change anything, but if you add these together now, you group your like terms. And then putting it into descending order is always good. So I can't group anything with my x squared, which is my highest degree, so it's going to go first. I can't group anything with my 3x, so I have plus 3x. And then I have plus 2 minus 4, so now I have minus 2. So now you have grouped those two functions together to create a new function. So that is how we do a combination algebraically. Later on in the slides, we'll look at how we can combine graphs. So, and we'll look at a way of solving these piecewise or algebraically. Sometimes piecewise is a lot easier. So that's the sum, addition. Well, what's our next operator? The difference, which is subtraction. Now, in this case, the notation changes, but very subtly. The only thing that changes, obviously, is our sign. So now we are subtracting. And this is where you get the important distinction of the two functions and using brackets, because now we get 3x plus 2 minus x squared minus 4. So it's important in this case that you remember to water bomb in the negative distributive method and you subtract everything. So now you have 3x plus 2 minus x squared plus 4. And then again, descending order is going to be negative x squared and then plus 3x. And now in this case, you get 2, and this ends up being a positive 4 because it's negative times a negative, so you get plus 6. So again, you combine them to get a new function. It's just slightly different because we have subtracted them. That is why brackets are super important, though. Don't forget your brackets. So next operator, product. That means multiplication. So here I have f of x times g of x, which can be written like that. Now be really wary here because that's a tiny little filled in hole, because the next booklet we actually look at something that looks like this, and you can see that that hole is not filled in, so that's different, okay? There's a difference between this and what we have on this page. Now on the page here, we are multiplying them together, which is why usually you'll see this without a dot at all. You'll just see FG, because that's still multiplication, because when you put two variables next to each other. So now what we're doing in this case is we're going to multiply them together. So we take 3x plus 2 and we multiply it with x squared minus 4. And we have two binomials here, so we can use FOIL. So 3x times x squared gives us 3x cubed. And then 3x times negative 4 gives us minus 12x. And then plus 2x squared, and then last is minus 8. Now, again, always good to put it in descending order. So 3x squared plus 3x cubed plus 2x squared minus 12x minus 8. So we've multiplied them together and we've created another new function. So you can use FOIL when it's binomials. If you have more, though, you're going to have to use the distributive method. It gets a little bit messier. So what's after multiplication? Division or quotient. So in this case, yes, we are dividing the two functions. Really important, whatever function is in our denominator cannot be 0 because we cannot divide by 0. The whole world blows up. So here we have our two functions, and now we are going to do 3x plus 2 over x squared minus 4. Now, you could simplify these, and we will get into simplifying these. You can't factor the top, but you can factor the bottom. It's a difference of squares. If you don't remember your factoring, go back to my grade 10 factor videos. So Why that matters is because it matters what the bottom is not allowed to be. Remember that the bottom is not allowed to be 0. So what makes that happen? Well, that happens when either the factor on the left here is 0 or here is 0. And what x value will make that happen? That happens when x is equal to plus or minus 2, which means x is not allowed to be equal to plus or minus 2. And that is an example of a domain restriction. So that's what we talked about in the first 2.1 video, right? We have a domain restriction. X doesn't exist there, not allowed to be there. You're not allowed to have a denominator of 0. So keep that in mind as we continue to work through these. So let's practice some. Now, like I said, you can solve these algebraically or you can solve them piecewise. I'm going to show you both. So I'm going to start here algebraically. Because algebraically, we simplify the functions first. And if you have complicated functions, say functions that have denominators, algebraically might not be the way to go. Piecewise will be easier, and you'll see piecewise in a second. So f plus g of x means f of x plus g of x, which in this case means 2x plus 1. And sorry, you'll see in the next slide. We can't do these piecewise because we don't have a value for x. So we will see those later. 2x plus 1 and then plus g of x, which is x squared minus 2x plus 1, and now we add them together. So 2x plus 1 plus x squared minus 2x plus 1, x squared, the 2x's cancel, plus 2. So there is our simplification of f of x plus g of x if we're given those two values for our if we're given those two functions from our list of functions there, okay? So now what about h minus k? Well, h minus k means we have h of x minus k of x. Now, something interesting for k of x. K of x equals 2, which means we have a horizontal line at 2. So the x value doesn't even matter. So what we do here is we just sub that entire statement for the number 2, and then h of x is our x cubed minus 2, and boom. You're done. You can't do anything else. That is the arithmetic combination of those. So what if we throw in a value? So now we've thrown in a value. So what I'll do is I'll show you algebraically, and then I'll show you piecewise. I'll try and cram it in, but then I might have to erase it to make room for the second one. So you can see there's a lot happening here. You have k times g. Okay, so we'll do this algebraically first. So k times g means k of x times g of x, and then all over h of x. So algebraically what I have is I have k of x, well that's just 2, and then g of x is x squared minus 2x plus 1, and then h of x is x cubed. So you water bomb in that 2, and you get 2x squared minus 4x plus 1 all over x cubed. Now, this doesn't actually help us algebraically because you can see that I can't simplify it all, and normally what we're looking for algebra is that we can simplify the statement. And you can see here we can't. All we would then do is we would sub in our value 3 for our x's. So it would be 2 times 3 squared minus 4 times 3, and I'm going to have to erase this partition here, plus 1 all over 3 cubed, so that's 9, 18, minus 12, plus 1, all over 27. So what does that give us? That gives us 6, 7 over 27. So careful that you have done that properly, and that properly, and that properly, and there is my error. That should be a 2. That should be a 2. That should be a 2. See how easy it is to miss the water bombing. So show that water bombing to make sure you don't pull a me and make a mistake, which gives you 8 over 27. So I'm going to leave this on the screen for a second. So 8 over 27. Now a lot of you might be looking at that saying, wow, that's a lot. I'm not sure how I feel about that. So let's look at this piecewise then. And by piecewise, what we're doing is we are solving the individual functions first, and then performing the combination. So you go like this, you go, okay, well, what's k of x? K of x, well, that's just 2. Okay, what's g of x? Well, g of x is x squared minus 2x plus 1. Okay, so then what's g of 3? Well, g of 3, because that's what our input value is, g of 3 is 3 squared minus 2 times 3 plus 1. which means I have 9 minus 6 plus 1, which is 4. So now g of 3 is 4, and then what is h of 3? Well, that's just 3 cubed, which is going to be 27. So you have a value for h, you have a value for g, and you have a value for k. And if it's saying k times g over h of 3, well, k of 3 was 2, g of 3 was 4, and h of 3 was 27, and sure enough, that simplifies to 8 over 27. So me personally, I prefer the piecewise part, solving for the individual functions first, because it just makes life easier. We're not doing crazy algebra or anything strange like that. We're just, well, algebra isn't strange. We're just making life as simple as possible. So what I'll do here is I'll do this next one strictly piecewise. What we need is we need f of 1. Well, f of x is 2x plus 1, so that means we have 2 times 1 plus 1, so f of 1 is 3. We're going to need k of 1. Well, we see k of x is 2, so k of 1 doesn't matter, it's still 2. We're going to need h of 1. Well, h of 1 is 1 cubed, which is 1, and then we're going to need, it's h of 2. So sorry, see, I get ahead of myself sometimes. So when we're dealing with the h and the g, we're not looking for 1 anymore. H and g are of 2, right? There's 2 for h and g. So h of 2 is 2 cubed. So h of 2 is 8. And then g of 2, well, we're plugging it into a larger function. So 2 squared minus 2 times 2 plus 1, which is 4 minus 4, so 1. So we got a value for f of 1 and k of 1. So let's do that first. So f times k of 1 is equal to 3 times 2. And then we're subtracting h times g of 2, and h of 2 is 8, and g of 2 is 1. So we've done the hard work, and now we just plug in the numbers. So then we get 6 minus 8, and you get negative 2. So it's a lot, in my opinion, easier to do the questions in that sequence. So let's look at another one, and I'm going to do this strictly piecewise, okay? In the note, it's done algebraically, so you have an option to look at both, but piecewise is just a little bit more organized. And it helps, and again, ahead of myself, cannot do piecewise because I don't have a value here for x. I got to look at the screen before I start talking. So I have an x, which means you can't do piecewise because you can't actually solve your function. So what we have to do here is, yes, we have to work a little bit harder algebraically. So we have h times f plus g and all of that of x. So what does that mean? Well, what's my h of x? My h of x is x cubed. So, okay, I'm going to be doing x cubed times f of x plus g of x. So 2x plus 1 plus x squared minus 2x plus 1. So brackets, bedmass, we're going to do the inside first. So we're going to have x cubed times 2x plus 1 plus x squared minus 2x plus 1. Simplify the inside, group our like terms. So x squared is by itself. So now we have x cubed times x squared. My 2x's cancel. So x squared plus 2. And then your last step would be to water bomb in your x cubed. Remember your exponent laws. And you're going to get x to the 5 plus 2x cubed. So that is your new function. So let's say we did have a value in there for x, 2 or whatever, then you would plug a 2 in for there and a 2 in for there, and you'd solve from there. But we don't have that in this instance, so we can't. So you have your choice. When you have a value that we're subbing in for x, you can solve it piecewise or you can solve it algebraically. If you do not have a value, you have no choice but to do your algebra. Okay, so now let's look at this graphically. The important concept is that f of x, g of x are your outputs, right? Your y values. So you need to find your y values. If we are doing f of 3 plus g of 3. Well, what's my y value when x is 3? So on my f of x graph, where's x equals 3? 1, 2, 3. So I'm looking at this point right here. So my y value is -1. So I'm going to go -1. And then for g, when x is 3, I'm here at +1, so -1 plus +1. So the combination here is actually the answer 0. So you're looking for the given y values when you're at a specific x value. So let's look at another one here. So now h of 5 divided by g of 5. Okay, so where's h of 5? So my h of x graph here, I'm looking for an x value of 5, and I get this point right here. So I have a y value of 3. So that means I have 3. And then g of 5, well, here's 5 down. I'm right here at -1. So over -1, and I get -3. So nothing crazy going on there. You're tracking the y values of the given x values, and then you're creating your combined function from there. Now, how about a new graph? So if you're making the graph given from two graphs, so you're just subtracting here. We are subtracting our outputs, right? So in the first example, I've taken a bunch of particular x values, okay? So when x is -2, well, when x is -2, f of x is here, so f of x is +2. So +2, and then h of x is -4, so minus -4. Be really careful with the negatives there. And what do you get? I'm going to change to red. You might be able to see it better. 6. So on my new graph, when x is -2, my output is 6. So I have a point up here. So the next one, when x is 0, well, when x is 0, y is 0 for f of x. And when x is 0, y is -2, so minus -2. And what do you get this time? You get 4. So when x is 0, y is 4 on my new graph. Wow, sorry. No, look at me go. 0 minus -2 is 2. So I have a point there at 2. So now let's keep going. X is 1. So when x is 1, I have -1 for f of x minus -1 for h of x. Now let's see if I can do my algebra or my arithmetic properly. -1 minus -1 is 0. So I have a point at when x is 1, y is 0. So I'm on x-intercept there. And now what about when x is 2? Well, when x is 2, my f of x is at -2, and then minus, oh, look at that, 0. So I end up with -2. So when x is 2, my output of my combined function is -2. So I'm down here. And now what happens is you can see the lines actually become very similar in their slope. So when x is 4, y is 0. And when x is 4, y is 2. So 0 minus 2. And I get -2 again. Well, that just means I'm now here. And let's check one more. Well, when x is 2, or when x is 6, my y value is 2 for my f of x. And when f is 6, or when x is 6 on h of x, I'm up here at 4. So 2 minus 4. And again, I get -2. So it looks like I'm creating this trend here where I get a straight line. So my combined graph, my graph of f minus h is down to there, and then it's going to stay at -2 for the remainder of the graph. So you're graphing by subtracting the outputs of the given inputs from the graph we're looking at. Now, shaking off the rust, sorry, I made a couple arithmetic errors there, such as life. You bounce back and you pretend that the people watching these videos don't notice and or care. But deep down, it hurts. All right, good job. See you on the next video. We're moving into composite functions.